Hello and welcome back to Mahi's Magical Math. Today we are going to be doing the Level 1 to 11th hour practice questions set number 1. The strategies we'll be using today are drawing a picture and working backwards. So let's jump right in. Math Kangaroo 2006 problem number 2. Together, Chip and Dale have 8 nuts. They divided them equally between the two of them. Chip ate 1 nut. How many nuts does he have left? So let's think about this, okay? We've got Chip here. We've got Dale over here. They divided 8 nuts equally between the two of them. So 8 divided by 2 is 4. 1, 2, 3, 4 nuts for Chip. 1, 2, 3, 4 nuts for Dale. Chip ate 1 nut. So, that nut is gone. How many nuts does Chip have left? We can see that Chip has 3 nuts left. So the answer is 3. Great job. Let's move on to the next one. Okay, we're on to the next problem. MK 2012 problem number 9. 13 children are playing hide and seek. One of them is the seeker. After a while, 9 children have been found. How many children are still hiding? So let's draw a picture to illustrate this. So there were 13 children playing hide and seek, but one of them is the seeker. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 children are hiding, and the seeker is special. We're going to draw them down here. Okay, now, after a while, 9 children have been found. So let's X those off. 1, 2, 3, 4, 5, 6, 7, 8, 9. How many children are still hiding? It's these 3, all over here. Remember, don't count the seeker because the seeker was never hiding. The seeker is the one seeking. So our answer is 3 children are still hiding. Okay, Math Kangaroo 2007 problem number 15. The clowns at a circus are standing one behind another. Vivi said to Bibi, who is standing behind him, "Behind me, 4 clowns are standing." Bibi answered, "In front of me, only 3 clowns are standing." How many clowns are standing in the line? So we definitely need to draw a picture of this to understand how many clowns are in the line. Okay, so I'm going to make Vivi green. Here's Vivi. And here's Bibi in red. Bibi is standing right behind Vivi, as it says in the problem. So Vivi said, "Behind me, 4 clowns are standing." So behind Vivi, there are 4 clowns. So 1 is Bibi, then there are 3 more. Bibi answered, "In front of me, only 3 clowns are standing." So in front of Bibi, there are 3 clowns, one of whom is Vivi. 1, 2, 3. How many clowns are standing in the line? Well, let's count all of these black dashes that we made. 1, 2, 3, 4, 5, 6, 7. 7 clowns are standing in the line. Remember to draw a picture for these type of problems because it really helps you understand where everyone's standing and how many clowns are in front of each person. A dragon has 3 heads. Every time a hero cuts off 1 head, 3 new heads grow. The hero cuts 1 head off and then he cuts 1 head off again. How many heads does the dragon have? Okay, so here's our dragon with 3 heads. Now remember, you don't have to make it look pretty, but you just need to know that these 3 heads belong to the dragon. Here's our dragon. Every time a hero cuts off 1 head, 3 new heads grow. Okay, so the hero cuts 1 head off. This head got cut off. So like the problem said, 3 new heads are going to grow from this. 1, 2, 3. So the hero cuts 1 more head off. And 3 new heads grow from there. 1, 2, 3. How many heads does the dragon have? Well, now let's just count this. So we got 1 head, 2 head, 3 heads, 4 heads, 5 heads, 6 heads, and the 7th head. So the dragon now has 7 heads. MK 2011 problem number 20. Simon has 2 identical aquariums. There are 26 quarts of water in one and 42 quarts of water in the other. How many quarts of water does Simon need to pour from the second aquarium into the first in order to have the same amount of water in both? Wow, this problem has a lot of information. Let's draw some pictures to help us understand. So Simon has 2 identical aquariums. This one's the first one, the second one's identical, so here's the second one. There are 26 quarts of water in one, 26, and 42 quarts of water in the other. How many quarts of water does Simon need to pour from the second aquarium, which is this one, into the first aquarium, which is this one, in order to have the same amount of water in both? Now, there are 2 different ways you can solve this, okay? Let me show you the 2 different ways. Over here, we're gonna have way 1 and method number 2. Okay, so the first method you can use is just simply see that the difference between 26 and 42 is 16. 16 quarts of water. Quarts of water. If you want to pour water from the second aquarium into the first, that means the water level in the second aquarium is going down and the water level in the first aquarium is going up. So this means we just have to divide 16 by 2, which is 8. Now you'll see that 42 minus 8 equals 34. And 26 minus 8, or 26 plus 8, because the water level is rising, is also 34. So 8 seems to work. If you want to really check your work here, you can manually subtract 1 from 42 and add 1 to 26 and keep going until the water level is equal. So you would have 41 and 27, then 40 and 28, 39 and 29, 38 and 30, and so on, and soon you'll see that they indeed level out at 34, 36, 32, and all the way to 34, 33, and 34. It works! So, the amount of the quarts of water that you need to pour is 8. Math Kangaroo 2006, problem number 9. Lucy, Maria, and Anna have a meeting at 12:30. Lucy's walk takes 10 minutes, Maria's a quarter of an hour, and Anna's 40 minutes. At what time must the person who needs the longest time to get to the meeting leave her house? So let's write this down. Lucy, her walk takes 10 minutes. Maria's takes a quarter of an hour. So how many minutes are in an hour? 60, you're right. And when we say a quarter of an hour, that means that it's a fourth of an hour. So what's 60 divided by 4? 15, you're right. So Maria's takes 15 minutes. And Anna's walk takes 40 minutes. At what time must the person who needs the longest time to get to the meeting leave her house? Out of 10, 15, and 40, Anna's walk definitely takes the longest at 40 minutes. So what time must she leave her house at to get to the meeting? So if the meeting's at 12:30 and Anna needs 40 minutes to get there, we just need to go backwards 40 minutes from 12:30. So how do we do that? Well, we know that going backwards 30 minutes gets you to 12 o'clock. Now we just need to go backwards 10 more minutes. So that's 11:50 a.m. Anna needs to leave her house at 11:50 a.m. to get to the meeting on time. Math Kangaroo 2009 problem number 19. Grandma made some cheese dumplings and some blueberry dumplings. Altogether, she made 31 dumplings. If she had made 11 more cheese dumplings, then there would be the same number of blueberry dumplings as cheese dumplings. How many cheese dumplings did Grandma make? Wow, there's a lot of information in this. Let's break it down. So she made cheese dumplings, which we'll say with C, and some blueberry dumplings, which we'll represent with B. Altogether, she made 31 dumplings. So if you add up the number of cheese dumplings and the blueberry dumplings, you get 31 dumplings in all. If she had made 11 more cheese dumplings, then there would be the same number of blueberry dumplings as cheese dumplings. So for the number of blueberry dumplings and cheese dumplings to be equal, you need to have 11 more cheese dumplings. So the number of cheese dumplings plus 11 would equal the number of blueberry dumplings. How many cheese dumplings did Grandma make? Okay, so let's think about this. We can use a little bit of some substitution to make this problem work. If the number of cheese dumplings plus 11 equals the number of blueberry dumplings, then that means if you subtract 11 from the number of blueberry dumplings, you get the number of cheese dumplings. Now, we know that another way of writing C is just writing blueberry dumplings minus 11. So blueberry dumplings minus 11 plus the number of blueberry dumplings equals 31. Oh, so now with a little bit algebra, we can move this over here and add the B's together. 2 times the number of blueberry dumplings equals 42. So the number of blueberry dumplings equals 42 divided by 2, 21. We can go back to this equation and see that the number of cheese dumplings equals the number of blueberry dumplings minus 11. 21 minus 11 is 10. You got it. So how many cheese dumplings did Grandma make? We can see, after some math, arithmetic, that the number of cheese dumplings is 10. Okay, this is the last problem. Stay strong, mathletes. MK 2020 problem number 24. John and Olivia exchanged sweets. First, John gave Olivia as many sweets as Olivia had. Then, Olivia gave John as many sweets as John had after the first exchange. After those 2 exchanges, each had 4 sweets. How many sweets did John have at the beginning? This is a classic working backwards problem, and for any working backwards problem, it's always good to have a table. So let's draw one. So we want to have the amount of sweets they both started off with and what happened after each exchange. So let's draw this real quick. Okay, so we've got John, Olivia, and the total number of sweets during each of these exchanges. So now we have the sweets they started off with. We have after exchange 1 and after exchange 2. So we know that after exchange 2, each of them had 4 sweets. Let's write this in a different color to make it easier to see. So we know that after exchange 2, each of them had 4 sweets, for a total of 8. And we know that the total is always going to be 8, because no sweets are being eaten or thrown away or anything like that. So after exchange 1, Olivia gave John as many sweets as John had after the first exchange, and that's what results in exchange 2. So if Olivia is giving John as many sweets as John had, then that means the amount of sweets John has is doubling. So what's 4 divided by 2? That's 2. And if John had 2 sweets, then Olivia had 6 sweets to make it a total of 8 sweets. And first, John gave Olivia as many sweets as Olivia had. So Olivia's number of sweets this time is the one that's doubling. So 6 divided by 2 is 3, and that means John started off with 5 sweets. Now it's very important to go back to the problem and see what the problem is asking. It's asking how many sweets did John have at the beginning? As we can see in our table, we're looking at the beginning and we're looking at John. John had 5 sweets to start off with. Great job today, mathletes, and I hope to see you in the next video.